Hello dear colleagues. As a rule, the researchers now understand ecosystem services as the quite wide range of the forms of the use of the functions of ecosystem, based on the need of the society to use the natural resources in the sparing mode, which will not lead the natural processes and the individual ecosystems to depletion. Biodiversity has been and remains as one of the most difficult service which is amenable to research and forecasting. At the same time, the climatic changes influence on significantly both biodiversity as a whole, its individual components, and the welfare, well-being, of the person, which he receives on the basis of biodiversity. And if the influence of the climatic changes directly on the individual aspects of diversity is in the focus of the scientific research today, so the assessment of the influence of such changes on ecosystem services in the Ukraine has been studied weekly yet. On this background, realizing the need to move forward on the path to the solution of the actual problems of management of natural, semi-natural, and artificial ecosystems, there have been arisen the views which the authors have tried to express in the article. Dialectically, these views are not new, and they suggest gradually moving from the particular to the general, including the individual ecosystems or their composite biota in the research cycle, on the example of which it can be traced the possible qualitative and quantitative changes reliably that reflect on the socio-economic consequences of the exploitation of bioresources of these ecosystems inevitably. The research carried out in the framework of the project Building Capacity for a Black Sea Catchment Observation and Assessment System Supporting Sustainable Development, 2009 to 2013, of the 7 Framework Program. We have been made the attempt to present such consequences on the example of ecosystems and the individual elements of biota, which are significantly separated from each other at first sight, which have been the most studied, and the consequences of the exploitation of these resources can change the accents of ecosystem services. To such ecosystems, the use of resources by human lies on the surface and forms the significant services for the economy. We have attributed the ecosystem of the Sea of Azov with its historically established fish resources, the ecosystem of the delta of the Danube, where renewable storage of building reed has become the important branch of the economy, the zonal steppe ecosystems and their surrogate derivatives such as agro-ecosystems that will change inevitably under the influence of the different scenarios of the impact of climate. The presented results of the research will help people who make decision in the questions of the use of nature during the formation of the strategy of the sustainable development of the region. In literature, there are no unequivocal views about scenarios of climatic changes. In various geographic areas these changes manifest themselves differently. In addition, they are amplified by human interference and nature management. The analysis of hydrometeorological data in the Azov Sea basin gives a possibility to determine several, the most probable for the region, scenarios of climate changes: 1. Increase of temperature and increase of precipitation, 2. Increase of temperature and decrease of precipitation, 3. Decrease of temperature and increase of precipitation. Azov Sea ecosystems. Main trends of climate changes for the Azov Sea ecosystem are the following. Increase of precipitation and, correspondingly, the volume of river drainage is a major determinant of salinity. It influences on fish productivity, forming the food base in the former decades. Increase of salinity in the Sea of Azov brought about the appearance of the comb jellyfish Nemiopsis lidii, which greatly undermined zooplankton biomass and affected productivity of most short-cycle fish species: European anchovy Ingroiles and Chrysicolus and Azov sea sprat Ornithological triventris. For the Sea of Azov, we can forecast the changes of fish communities and general indices of fish productivity according to 3 above-mentioned scenarios. These scenarios can have a noticeable impact on socio-demographical situation in the region. First scenario will lead to decrease of salinity due to increased drainage of the rivers. This scenario is the closest to present conditions. Increase of air temperature will bring about increase of water temperature. As it was mentioned above, this trend will lead to further desalinization of the Azov Sea. Currently, the sea salinity which is typical for a natural condition of the sea. Further decrease of salinity up will not lead to any considerable changes in ichthyofauna structure. The European anchovy and Azov Sea sprat will remain to be dominating commercial species and current trend of their number growth will continue. The increase of stocks of these fish species will assist to improvement of socio-demographic situation in the industry. The increase of their catch will promote the growth of workplaces in extractive and processing fish industries. An important element of the development of fish extraction enterprises will be a possibility to catch fish using a fixed net in coastal waters without special vessels and trawls. It can assist to the development of small business in the coastal villages. Decrease of salinity lower than 9 will be critical for the Azov Sea ecosystem because under these conditions a majority of Ponto-Caspian species cannot live. In this case it is possible essential changes in the structure of communities negative for fish productivity and fish industry on the whole. An important consequence of increase of temperature will be increase of the frequency and area of suffocation phenomena. The combination of high summer temperatures and the calm lead to stratification of water and rapid decrease of the oxygen dissolved in lower water layers. The oxygen reduction lower than 3 mg/L results in mass mortality of bottom fish species, mostly gobies in present conditions, round goby Neogobius melanostomus, bullhead Neogobius fluviatilis, goat goby Neogobius fluviatilis, sermon goby Neogobius sermon, etc. As for the socio-economical situation in the region, acceleration of such phenomena will lead to the following negative consequences: decline in fish stocks of bottom fish species, decrease of profitability of fish industry because of worsening of the production, e.g. even alive gobies captured in pre-suffocation period are lower in price, worsening of aesthetical and recreational potential because of mass discard of dead fish at beaches of the region. Official data of the Azov Special Fish Protection Service show a trend of increase for the duration of suffocation phenomena and the volume of dead fish. Second scenario, increase of temperature and decrease of precipitation, will lead to increase of salinity due to increase of evaporation from water surface. This condition of the sea already was in the period of 1960 to 1980s. The only difference of that period was that the reduction of river drainage had anthropogenic reasons. In that period the sea salinity reached, which is again possible in case of decrease of precipitation and increase of temperature in the region. In this situation a negative role of the jelly-like organisms in formation of food zooplankton will grow, which will further result in reduction of stocks of the anchovy and Azov Sea sprat. In these conditions number of jobs in fish extracting and fish processing industries will considerably reduce because of decrease in fish catches. An alternative commercial species may be the soyui mullet, Lysa hematocylus. It is an euryhaline species and in case of increasing salinity its number may grow. However, it should be noted that the number of workplaces connected with the soyui mullet catching is fewer than in case of catching and processing of the anchovy and Azov Sea sprat. That is why this scenario will apparently bring about the tension in fish industry of the region. Third scenario will lead to decrease of salinity and air temperature. It will be similar to the first scenario, with salinity as a main factor. In the last decade main commercial groups of fish species have been already changed. Thus, to date valuable sturgeon species, Acipenseridae, are lost, the pike perch, Sander locioperxa, the turbot, Cetatoros, and many freshwater species. At the same time, decrease of salinity and reduction of jelly-like organisms lead to increasing stocks of the European anchovy and Azov Sea sprat and positive trend of the round goby. Climate changes will have an essential impact on the success of reed harvest. The observed rise of Black Sea level and increased frequency of wind-driven water level fluctuations may result in increase of water level in the secondary delta of Kielia branch of the Danube delta, reduction of the reed bed surface area and increase of cattail reed associations. Trend of decrease of flood water level in the Danube will lead to expansion of saline meadow and marshy meadow communities on high ridges, with low percentage of the reed. In case of hot summer also the increase of fires frequency is expected. It will lead to changes in vegetation and formation of a marshy meadow communities. This process of meadow formation in Plavny is already observed on considerable areas of the Kielia Delta. The fires will change the cell membrane structure of the reed due to accumulation of ash constituents in soil which make parenchyma thinner, and the stalk more fragile. The latter will substantially reduce its commercial value. Shortening of the harvest period directly in Plavny as a result of delaying leaf fall and considerable fluctuation of water level will lead to survival of only powerful harvesting companies which will be equipped with Sega combines. Increase of a portion of the cattail reed communities will result in a new activity of local people, winter cattail harvest of the which is already appearing at the labor market. According to the results of the monitoring in the North Azov region in 2010 to 2011, we have noticed a meadowification trend of steppe communities due to increase of phytocyanotic role of Elytrigioripans, Cynodon dactylon, on dark and light chestnut low fertile soils. In addition, retrospective data for the period 1952 to 2011 show a clear phytomass increasing trend for steppe communities with the dominance of Stipa capillata. Phytomass growth is a direct consequence of increasing amount of precipitation and air temperature. If this trend of increasing precipitation and air temperature continues, it may lead to meadowification of southern steppes. Meadow vegetation communities take an insignificant portion within the studied section of the coast, and changes in their structure cannot cause any serious economic effects. Though, at the local level, changes of the meadow community's productivity can have a substantially effect on productivity of pastures and hay fields. Thus, for 2 years of observation, 2010 to 2011, phytomass of meadow communities with the dominance Elytrigioripans in monitoring areas had a positive trend. In case of the first scenario, increase of air temperature and decrease of precipitation, the productivity of Puccinelia gigantea meadows can reduce 2 to 3 times. Respectively, number of grazing cattle or volume of haymaking will be also 2 to 3 times reduced. With average productivity of these communities of green mass and market price of hay in the region as 1 UAH, loss because of lack of forage, for a single mowing, would be equal from 500 to 520 thou. A year, e.g. monitoring plot at the right coast of Molokny Lyman. In meadow communities of Elytrigioripans the productivity can drop 6 to 7 times, and the loss will be about 80,000 UAH. In case of the second scenario, increase of air temperature and increase of precipitation, the productivity of meadow conasses can rise by 20 to 30%. In this case the overall commercial volume of hay can increase to from 600 to 750 to 800 thou. UAH/year, total for monitoring plots of Molokny Lyman and Savashik Bay. At the present time, a major profitable type of activity in steppe areas is the cattle raising. The situation in the Azov-Black Sea region, observed in 2010 to 2012, are connected with extreme high temperatures in the spring-summer period, and except for direct increase of air temperature and drought of soil, it leads to the considerable reduction of the watering area of near-water habitats and creates very favorable conditions for transformation of the locust, Locusta migratoria L. in the gregarious, invasion, form. This situation is worsened with embankment and regulation of most rivers flowing into the limans of the Azov and Black Seas. Long-term observations show that potentially the most dangerous localities of the locust in Ukraine are the Danube River delta and lower reaches of the rivers entering into the eastern part of the Azov Sea. In 2012, the locust invasion has seriously damaged agricultural lands in south regions of the Russian Federation. But appearance of the locust outbursts at the Ukrainian Black Sea coast is only a question of the time. The situation with its harm to agriculture is worsened by imperfection of means of struggle against the locust, above all different pesticides. Implementation of new and high-effective chemical, hormonal, and biological means of struggle, which will also entail the rise of financial costs for the harvest protection. These examples give an additional confirmation that phenological responses include not only a shift of insect development at the start of the season to earlier terms but further changes in phenology. Thus, phenophases, connected with the end of seasonal development, on the contrary, usually shift to later dates. It leads to prolongation of a period of active development, including that for pests, which can provide extremely negative socio-economic effects. The global changes of climate cause the fluctuations of the natural conditions which determine the vital processes and the state of the individual species, grouping, ecosystems. At the same time, all existing scenarios have negative changes, and they differ only in the large-scale negative transformations and the terms of the occurrence of the number of threats. For the Azov-Black Sea region, the climatic changes lead to changes not only at the level of the transformation of grouping, but also exert influence on the socio-economic conditions of the region. It has been investigated that changes of the salinity of the Sea of Azov, the increase of the water temperatures, lead to suffocation phenomenon of resource species of fish and the decrease of the general fish productivity. The similar negative changes have been determined for the delta of the Danube, where as the result of the increase of the summer temperature by 2 there is the dislocation of the terms of the development of reed and its transition to the winter phase. It leads to the additional costs for the processing of the important building materials, and, accordingly, it affects the profitability of laying in of reed. The amount of precipitation determines the state of meadow grouping in the basins of the small rivers of Priazovia and can affect significantly the productivity of pastures and hay fields. So, for 2 years of the observations, 2010 to 2011, the phytomass of meadow grouping with dominance of Elytrigioripans in the zones of monitoring has had the positive dynamics. It determines the profitability of stock breeding in the region and affects significantly the socio-economic development of rural areas. Extremely high temperatures in spring and summer period, except the direct increase of the temperature of air and soil drought, lead to the significant decrease of humidity, which creates the favorable conditions for the transformation of locusts, Locusta migratoria, in herd, invasive, form. The mass development of this species can affect significantly agriculture of the southern regions of the Ukraine. In general, it should be noted that the different scenarios of the climatic changes affect the quality and availability of ecosystem services in the Azov-Black Sea region.